Okay, so the next question that we have is question number 5, which is ax plus b over cx plus d. So if you have, basically, if you want to calculate d by dx of ax plus b over cx plus d, all you need to do is, of course, you can use the quotient rule, u divided by v whole prime is equal to u prime times v minus u v prime over v squared. So then it's pretty simple. So you can write this as u prime, meaning d by dx of ax plus b times cx plus d times, so I put this in brackets, meaning that I'm taking only the derivative of this part, times basically cx plus d minus the first function, which is ax plus b, times the derivative of the second function, which is d by dx of cx plus d. The derivative of cx plus d. Now, and then you divide that by cx plus d divided by 2. So of course you know that the derivative of ax plus b is only a. So a times cx plus d minus the derivative of cx plus d is only c, so c times ax plus b over cx plus d whole squared. Cx plus d whole squared. So that's basically that. So question number 5. And of course you can probably simplify this as they have done. So they have written this as acx plus ad. So they have written this as acx plus ad minus acx minus bc over, and these two you can cancel out, over cx plus d whole squared, which is the same thing as ad minus bc over cx plus d whole squared. So that's ad minus bc over cx plus d whole squared. The next one is question number 6, which is 1 plus 1 by x over 1 minus 1 by x. So suppose that you want to take the derivative of 1 plus 1 by x over 1 minus 1 by x. I want to take the derivative of this. This is the quotient rule, of course, but I suppose you can put these together. I don't know which way it would be easier, but let's see. If I write this as if I use the quotient rule, I would have to take I would have to basically write this as u prime times v minus u v prime over v squared, meaning that I would have to take the derivative of this function and then multiply it by this function, and then take the derivative of the second function over here multiplied by the first function, and then raise this to the second power. Now, to take the derivative of this function, I would have to write it as d by dx of 1 plus d by dx of 1 by x, for example. And if I write 1 plus 1 by x, this would be basically x plus 1 I think that way would be easier, because this way then you have, again, you have the but let's do it this way. Let's see what happens. Of course, this way would be much more, a little bit more complicated. So I'm going to write this as d by dx of, so 1 plus 1 by x is equal to x. So that is x plus 1. So that is 1 plus x, for example, over x. And this would be x minus 1 over x. Okay, so it seems that we can simplify this thing, but you need to make sure that, basically, you need to make sure that, now you see this function over here, this function is not defined where the denominator is equal to 0. So if I have 1 minus 1 by x is equal to 0, and then negative 1 by x is equal to negative 1, 1 by x is equal to 1, then x is equal to 1. At x is equal to 1, the function is not defined. So that means that x is not equal to 1. And if your function is not equal to 1. So if your function is not equal to 1, that means that the derivative of your function, which is the slope of the function at point x is equal to 1, of course, is not defined either. So you need to be careful about that. But otherwise, if you know that your function is not defined at 1, then of course you can simplify x and x and write it as d by dx of 1 plus x over 1 over x minus 1, which is again the same thing really, meaning that if x is equal to 1, again the function is not defined. Okay, so what that means is that now I can use the quotient rule, meaning that I can write this as basically d by dx of 1 plus x times this function over here, x minus 1, minus the first function 1 plus x times the derivative of the second function x minus 1 over x minus 1 whole squared. Now this is equal to basically this is just 1 times x minus 1, which is x minus 1, minus d by dx of x minus 1 is 1. So 1 times 1 plus x is 1 plus x, so that's 1 plus x over x minus 1 whole squared, which is equal to x minus 1 minus 1 minus x over x minus 1 whole squared, which is x and negative x, so that's negative 2 over x minus 1 whole squared. That is the derivative of your function. Number 6, negative 2 over x minus 1 whole squared, and of course x is not supposed to be equal to 1, And also x is not supposed to be equal to 0. That is also true because in this form, as you can see, if basically if x is if x is equal to 0, then the function is not defined. So these two conditions have to be basically observed. Okay, so question number 7 is you want to find the derivative of, meaning d by dx of 1 over ax squared plus bx plus c. Ax squared plus bx plus c. So this might be something interesting or useful if you want to use it later. So basically we said that if you have u divided by v whole prime, that's equal to u prime times v minus u v prime over v squared. Now if your u is 1, then of course this would be equal to 0. So then if you calculate only this part, as we did before, then that would give you the derivative of this function. So you have basically negative u, which is basically negative 1 times v prime. So that would be the negative of d by dx of ax squared plus bx plus c over v squared, which is ax squared plus bx plus c whole squared. Now d by dx of ax squared plus bx plus c is, well, of course this is multiplied by this whole numerator. So you can write this as the negative of, for example, d by dx of ax squared plus d by dx of bx plus d by dx of c over ax squared plus bx plus c whole squared, which is equal to negative of basic d by dx of ax squared is, so when you have some constant over here, meaning that when you have d by dx of, for example, ax squared, a is a constant. So you keep the constant and then take the derivative of your function, or of your variable basically, which is basically a times 2x, which is equal to 2ax. So d by dx of ax squared is equal to 2ax. Now d by dx of bx is equal to b, and d by dx of c is equal to 0. And you need to divide that by ax squared plus bx plus c whole squared. So that's the derivative of your function. That means that d by dx of 1 over ax squared plus bx plus c is equal to negative 2ax plus b over ax squared plus bx plus c whole squared. If my answer is of course right, which I believe, negative 2ax plus b over ax squared plus bx plus c whole squared. That the answer is correct. Now, if you have, for example, if you want to calculate, for example, d by dx of ax plus b over px squared plus qx plus r plus r. So you can use the quotient rule. The quotient rule is u divided by v whole prime is equal to u prime times v minus u v prime over v squared. So then you can write this as basically u prime, meaning d by dx of ax plus b, d by dx of this, times the second function in the denominator, which is px squared plus qx plus r minus u times, so ax plus b, times the derivative of the function in the denominator, which is px squared plus qx plus r. When divided by denominator whole squared, which is px squared plus qx plus r whole squared. So now over here you have d by dx of ax plus b, which is only a, so a times px squared plus qx plus r. Now the derivative of basically the derivative of d by dx of px squared plus qx plus r is equal to d by dx of px squared plus d by dx of qx plus d by dx of r, which is equal to basically 2 times 2px plus q, and this is 0, and that is 0, so 2px times 2px plus q minus, basically the derivative of this is 2px plus q times this function ax plus b divided by px squared plus qx plus r whole squared. And suppose well, I think I wrote something wrong here. Yes, no, I didn't. Number 8. Okay, so if you simplify this, what you will get is basically apx squared. You will get apx squared plus aqx plus ar minus 2px times ax would be 2px times ax would be 2 times apx squared, 2 times apx squared 2 times bpx minus 2 times bpx minus aqx minus bq over px squared plus qx plus r whole squared. So over here I have 2 apx squared, so negative 2 apx squared plus apx squared, that would be negative apx squared. Negative apx squared. So apx squared negative 2 apx squared is equal to negative apx squared. 2 bpx, negative 2 bpx. Now aqx and aqx you can simplify, plus ar minus bq over px squared plus qx plus r whole squared. That's your answer. That is number 8. So number 8 is negative apx squared, negative 2 bpx plus ar minus bq over px squared plus qx plus r whole squared. And then the rest of them are basically the same story, basically. For example, number 9 is just a reciprocal of this function, meaning that you want to find, for example, d by dx of px squared, d by dx of px squared plus qx plus r over ax plus b. I want to find the derivative of this function. So based on the quotient rule,